Okay, I've got the tip panel tacked down around the periphery, and just to finish up sealing it at the joint. One point that I like to make here is that whenever you're working with balsa-rite, you're going to get it on the iron. And if you don't get it off the iron, then you're going to smear it around on the covering. So basically, if I get a little balsa-rite on the iron, I just rub it on my pants leg, and that cleans it right off. Or you could use a towel or a rag. But it's no big problem. It's just something that you need to keep in mind. So I've now tacked it around the edges. I'll go ahead and seal it down like we did on the main panel. Again, just pulling it slightly, not putting any tension on it, but rather just causing it to lay out smoothly on the surface. Using the tip of the iron, sealing down about 1/8 of an inch wide strip on the front of the trailing edge in this case. Okay. Now we'll turn the wing around and we'll do the same thing to the leading edge. Better tack it a few more places. I had only tacked it at the ribs. So now we'll tack it down a few more places. And then we can go back and seal it down along the bottom of the leading edge. Okay. Now I'm not going to go all the way out to the tip here because and I'm also not going to seal the material along the tip either. I want to wait until we get out there and I start talking about compound curves and how you can accommodate for those. But right now, we now have the material on the outside, so we can go back and shrink up the last bay of the main panel. Again, being sure, using the back of the iron as the edge, being sure that you don't get over that adhesive joint. Okay, a little bubble in the trailing edge there. Use the edge of the iron too. It's just you want to keep from getting that joint hot. Now at leading edge, we can work toward the middle. Okay, that shrinks up nicely. Get that leading edge just taken care of. One thing that I should also mention here is that you can pull this stuff with the iron. You know, even after it's sealed down around the edges, if you got a little wrinkle and it doesn't act like it wants to come out, you can just gently press with the iron and heat the material on the leading edge in this case, and slide the iron and just pull the wrinkle right out. So you don't have to depend on shrinkage completely to get the wrinkle. And as I mentioned before, you can always go to higher heat, and that's kind of as a last resort. That's why I like to use as low a heat as possible initially, because that then gives me a lot more reserve So now we're going to start shrinking the tip, and you can, this is where you have to really be careful not to get over that adhesive joint where the orange and the yellow go together. Using the heel of the iron just inside that joint. We're shrinking the material. Or the edge. Oh yes, now it's coming up nicely. Nice and snug, nice and tight. Again, working from the edges towards the middle to get that material nice and tight. Might be a little confusing on what I just said there. I have mentioned earlier you always work toward the edge, but that is when you're sealing the material down. When you're shrinking it, I've found that it works very well to work from the edges toward the center. Okay, we're almost out to the tip now, so I'm going to stop shrinking here, and then we're going to talk about what to do about compound curves on the tip. I'm just going to give you a little bit of an introduction right now, because the bottom of the tip is usually not the problem. Where people get into trouble is on the top side of the tip. Now, since this wing is essentially a straight taper, there's not going to be a whole lot of problem when we get around the tip. But when I start to cover the top here and get to this point, I will make it a point to tell you a technique that I've learned which takes care of real compound curves on tips, such as where you have an elliptical tip with a tapered section. Okay, now the idea with compound curves is that you either end up with too much material or not enough. So the basic principle of this technique that I've used is that before you nail or seal anything down, you shrink the material. In other words, holding it up in the air, put the iron on it and shrink it. And it kind of curdles up, but it reduces the amount of material that you have. And then, once you've shrunk it, then you can stretch it. So what happens is that the material, when it's unsupported and heated, it will shrink. But when you heat it, you can also pull on it and stretch it. So by alternating the heating to shrink and the heating then and pulling on it to stretch it, you can work it around some very severe compound curves. Now, in this case, all we really have is just the curve of the tip fairing, and that's not going to be that big of a problem. But I have pre-shrunk it, so now what I want to do is I want to heat it and stretch it. I want to heat it back here, back in this area, so that I have a greater area of material to start to stretching, and then I'll stretch it around the tip and iron it down as I go. And I guess I'd like to make the point that you go around the tip much further than you actually want the material to go. So then, once you get it around the tip, then you can peel it back a little bit, trim it off with the razor blade, then reseal it down, and it'll be a nice, clean, nearly perfect covering. So with that, I guess you can watch here while I do this. I'm pulling, and I'm putting quite a bit of tension on it and heating it back in the area. This curve right on the tip of the leading edge is a fairly sharp one, so you can see I'm heating it and pulling it and heating it, bending it around the curve. This stuff will stretch unbelievably. And that's the real key, to shrink it up initially and then re-stretch it in the areas where you want it to be stretched. Okay, I'm going to stop with the compound curve right there because I don't have the trailing edge completely sealed down yet, so I'll go back and do that. And I think you see the technique for tips and compound curves. Now, the same technique works whether the compound curve is just in this area or if the compound curve is from here on out. You shrink it and then heat it and stretch it and seal it down as you go. That is the approach. So we'll come back when I start cutting and fitting the pieces for the top of the wing, and I'll show you how to do that. At this point, we've got the bottom of the right-hand wing panel completely covered, and there's one last step that needs to be done before we turn the wing over and start covering the top. And that is to poke a hole in each bay of the wing so that the air can escape when you're shrinking the covering on the top. I usually put the holes in the bottom because they're not as obvious that way. But you must allow for that heated air, which is going to expand when you're trying to shrink the covering on the top. You must allow that some means of escape, otherwise it's going to blow up the covering like a balloon and you'll never be able to get it shrunk tight. So I just take a T-pin and poke a hole in each element of the wing that is going to end up being a sealed section. So around here we've got 1, 2, 3, 4, 5, 6, 7, 8 of them that are going to end up being sealed sections because these are all full depth ribs. So 1, 2, 3, 4, 5, 6, 7, 8. That takes care of all of that section of the wing, and then one more of those around here. And then we'll take care of the tip. Okay, and now we'll take a look at the wing panels we've covered to make sure that we haven't induced any warps other than those that we built in. And now we can also go back then and seal down the covering to the ribs. Remember, we put 2 coats of balsa on the ribs to assure that the material would adhere and thereby lend some structural stiffness to the overall wing. So we'll just go back and run the iron over the ribs, pressing the covering down, making sure that it has adhered to the ribs. Again, being careful around this joint and the colors, because we don't want to heat that joint up and let the material pull away. I guess there's one comment I can make. You know, balsa never cures, if you will. In other words, it always remains thermally active. So even years later, you can go by and, using heat, soften the adhesion and uncover the wing. And in fact, that's how I do it. If I get major damage where I need to have the covering off of a section of the wing, I just use the iron and cut it and then start peeling it up and then just pull it up and take the iron right ahead of where I'm pulling. And you can pull the covering right off and do your repair, and then recover. Get these wing ribs on the main panel sealed down. The reason I suggested sighting the wing and making sure that it doesn't have any major covering-induced warps is that the more loose material you have available, I believe, in other words, if you haven't sealed down the material to the ribs, I think it's easier to take a warp out that you may have induced when shrinking the covering than after you've sealed it down. And primarily that's because you're working with smaller sections of covering that have to stretch and shrink in the untwisting process. So I try to get all that taken care of before I seal it down to the ribs and essentially divide up the covering into small segments. Okay, that's that. Now, one last thing to comment about, and that is how to prepare the edge of the bottom covering to receive the trimmed edge of the top covering, or adhere it. Well, there's a couple ways to do it. One is to just paint balsa right on top of the bottom covering, and the other one is to cover the top and then trim off and then paint balsa right on the loose flap. I've done it both ways, and it's kind of a toss-up. There are advantages and disadvantages to each way. The disadvantage of painting it directly onto the bottom covering is that you always leave some exposed balsa, which you have to clean off some way or another. The primary disadvantage to just covering it and then painting the trimmed edge on the inside with balsa is that you have to be very careful to brush it out of the crack, or you end up with a buildup of coverite in there, and then when you try to lay it down, you get I call them a glob of coverite, a coverite glob, or rather, a balsa glob bubble. So you can kind of take your choice. I am going to, in this case, paint the bottom covering. So let me get set up for the laying out of the top covering panels, and I'll be back. Okay, ready to start covering the top of the wing. The point that I wanted to make here is that whenever you have a dihedral joint in an airfoil section, the line on the end of the panel of covering is not a straight line. It's a curve. It's a curve similar to the airfoil curve. So the way I make that curve on the end of the covering material is to lay the blank piece on there, and then with the flare pin just draw the line right down the seam, freehand. Then take a pair of scissors and cut along that line. And again, it's a cut and try sort of a thing. But usually you can get it in one or two cuts. Now the joint that I'm working on right now is not all that difficult because it's only 10 degrees. The angle that we're trying to accommodate is only 10 degrees. Now when we get out here at the tip, where we've got a 20-degree angle, and we're trying to fit that tip piece of covering on here, then there's going to be a pretty decided curve in it. So, we've trimmed that out on the first cut. Take a moistened Kleenex, wipe off the residue of the flare pin, and then lay the covering material on there and see how it fits. Yeah, it looks pretty good. Okay, now we want to do the same thing out here, but remember we're going to overlap it and tuck the covering down and glue it to the outside face of that joint rib there, so we want to leave a little extra. We want to make sure that we leave enough on this end to get to the middle joint. And then we'll just draw it. Actually, it's important to do this before you start trying to seal it down, because the material that is laying up on the tip panel is going to cause you problems when you're trying to seal down the edges and stuff. So you want to get as much of that out of the way as you can before you actually even start sealing it down. I'm leaving about 1/8 of an inch overlap there. We're still in good position here at the center of the wing, so that ought to about do it. Oh, we'll trim that off. And you can see I'm not going to any great pains to draw a nice clean straight line. I'm just trying to get an average curve there, which I can then smooth out with the scissors as I'm cutting it. Take the damp Kleenex and wipe off the ink. And left a little bit of a smear there. And then lay it on there. And you can see that it lays much nicer now. It almost is laying on the surface that we want to cover. So we can start tacking it down, again using the same approach that we used on the bottom. And that is working around the open bay first, then sealing it down to the seated center section. Tack it there, and we tack it. Now we don't want to get any motion in it here, so we're going to make sure that it's straight. Tack it down there. And using the triangle theory that we talked about before, we pull it down in this corner, laying it out smoothly in that triangle. The triangle goes from there to there. And we'll do the same thing at the leading edge. And we'll just tack it. And we'll do the same thing here. Now here we're working on this triangle. Tack it here. And then catch the back corner near the center here. And then we're ready to start tacking it down. So let me go ahead and do that. And if I think of anything else along the way, I'll come back on. Otherwise, I'll come back when I'm ready to start fitting this piece of covering for the tip. Okay, now we're ready to fit the top panels of the tip covering. And again, we need to work out that curve so that we get a nice wrinkle-free joint. So I'll, again, draw with the flare pen right down the center of the rib. And trim it out. I have put 2 coats of balsamite on top of that tip root rib, on top of the yellow covering, which will make sure that this covering adheres. Also, a little later on, when I put the trim on, you'll see that I use a strip of trim tape there, which also helps to keep that joint from pulling loose ever. Wipe off the ink residue and give it a check fit. And it looks pretty good. I'm using an 1/8 of an inch overlap. That's the width of the rib there. And I think that'll be all right. So let me go ahead and tack that down. A few more words about compound curves right out there at the tip again, just to remind you of the basic principles when we get there. And then we should be pretty well done. So I'll be back in a little bit. And it just occurred to me that you may indeed want to watch how I trim or tack down that critical joint there. So I have tacked it down right on the spar, and I'm laying it out smooth to the tip of the spar. And again, remember, working in triangles, I'll take this and lift it up and make sure that it's lying smoothly. And then I'll tack it down at the corner. And then I'll tack down the orange, but always with the iron moving toward the yellow. Because we don't want to build up any bunch up of material in the orange, because that would be the critical shrink point right in this area. So I'm using the iron and I'm pulling away from the tip as I seal that down. Okay, it looks like we've got a nice joint. All right, there. It's sealed down there. Now we'll do the same thing at the leading edge. Again, lifting it up, making sure it's laying down smoothly, and touching it, touching, and then sealing it down by moving away from the orange. And it's important to have good light when you're doing this, because by moving and getting the light reflection right, you can see where it's sealed down, where it isn't, and if there are any wrinkles developing. So there's that critical joint made, and I'll go ahead and finish up the rest of it. There's no magic there. Oh wait, now I got the wing fully covered. I thought you might like to see how I straighten it up if you do get any covering-induced warping. The way I check for warps is to take the wing and sight it into a bright light, and I line my eye up along one of the dihedral joints lines, and then tilt it until that line just disappears, and then without moving my head, I swing my eye down along the leading edge and see if I can see the trailing edge back at this point. And in this case I can, which means that the wing is warped this way. So what I want to do is twist it a little bit of leading edge down and try to get it flat, because the wing wants to be flat on the tips and the left center panel, but with the twist that we built in on the right tip, or the right main panel, excuse me. So the way I do this is I just kind of clamp it between my legs, take the iron, and twist the panel that I want to warp, and then just run the iron over it and take the wrinkles out. Because when you twist it, wrinkles will appear. Again, being careful not to heat that joint of the covering. And you can actually feel the covering relax and the effort that you have to put in to twist it reduces significantly as you go through this process. I might also comment here that I just weighed the wing, and we beat the overall weight goal. It only weighs 91 grams, which I think is quite good. And the wing is very strong and stiff, too, so I think it's going to be very successful. Let me check this thing again and see if we got the warp out. And it looks very good. Now, there was one last thing that I wanted to show you, and that is, we've talked about making sure that the covering adheres very well to these ribs to add to the structural stiffness. The way you do that is to take a Kleenex and rub down on the rib behind the iron to press the covering down as the adhesive cools. And that way you ensure a good adhesive bond to the ribs by the covering. You can't depend upon just the iron to do it. You need to put a little bit of pressure behind the iron while the adhesive is cooling in order to make sure that it stays adhered. And being careful when you get toward that covering joint. Now you also do the same thing with the spar. Make sure that the covering adheres to the spar. Very good. And the turbulator spars. Yep, the wing is sliding a little bit on me there. But we got the job done. Now we go over the diagonal ribs at the leading edge. Now the turbulator spars do a lot to structurally stabilize those diagonal ribs in the front, but the bottom of the rib is fairly free, so you need to make sure that the covering adheres very well to the bottom of these diagonal ribs on the underside. So with that, the next step is I'll show you how I make my numbers and put them on and put on the little trim, and then we'll be done with the wing. Now it's time to make the numbers to put on the airplane for your AMA identification. My number is 7642. I've already cut out the 642. They're the hardest ones, so I thought I'd just show you how I do it with the 7. 7's a pretty easy one to make. I just take monocoat trim sheet, is what I'm using. In this case, I'm using black, since the wing is yellow and orange. So I use a contrasting color of black for the numbers. Take the pattern. I have some patterns that I've saved, which is really nothing more than trim sheet backing that I've saved from some previous set of letters. And I draw around those on the back. I guess the only thing that's significant here is that you need to make sure that you turn your numbers over, face down, if you will, so that when you cut them out and go to stick them on the airplane, they'll be facing the right direction. And I just use the steel scale and a sharp knife to cut the numbers out. The numbers that I've selected and always use are just the common old block numbers, which are relatively easy to make. Okay, one more cut and we should have that 7 free. Then I can show you how I put them on the airplane. Many of you may already know the trick that I use. It's basically just using some kind of a detergent solution to allow you to position the numbers so that they don't, before they adhere. But before we do that, let's take a look at the trim. And what we want to do is put a little bit of a strip of trim at this joint. It not only improves the appearance of the airplane, but it also helps this joint maintain its integrity. If you recall, I mentioned that before. What I'm using here is monocoat, not monocoat, Coverite stripes. I'm going to take a 1/4 inch strip, measure it out. It's got to be at least twice that long, and cut it off. Then just pick it up from the backing sheet. Be careful that you don't get it tangled up and touching you. And then just position it over this dihedral joint rib. Try not to pull on it because this stuff is vinyl, and you can indeed stretch it, but if you stretch it, then it will pull itself back also. Now you notice that I left a little bit of tip hanging over the back here. We wrap that around. If you read the instructions on this stuff, it says don't expose the bare edge. Oops, uh-oh, got it stuck. Pull it off very gently. Don't leave a bare edge exposed to the airframe, or to the airstream rather. And just line it up and lay it over there. Press it down. And pick it up a little bit and slice it off with a knife. And there's the stripe on there. Now the numbers are self-adhesive also, and so in order to position them properly, you've got to have some way of moving them around. Otherwise they'd stick immediately and you'd never get them loose again. So what I do is I use 409 or Fantastic or something of that general type. Just lay out the numbers initially. I generally use the spar as a guide. Either put the numbers behind the spar or the top of the numbers above the spar, which is what I'm doing now. Kind of take a look at it and see where you want them. Okay, that looks pretty good. So we know we want the 7 over this one rib here, and then we'll space the rest of them by eye. So take the 7, take the 409 in this case, spray a little puddle of it on there and spread it around with your fingers. And take the number off the backing and put it down. Now you can see it slides all around, and I can position it and get it lined up exactly where I want it. Then I take a Kleenex or a paper towel and wipe the detergent off the wing and sort of squeegee it out from under the number at the same time. Now it takes 2 or 3 hours for this to dry, so there's plenty of time. Even after I've squeegeed it once here, you see that I can still move that number around. Make sure it's exactly where I want it and that there are no wrinkles in it. And one last time, squeegeeing it, holding it, and pulling away so that I don't introduce any wrinkles in it. And there's the 7 in place. And that's all there is to it, so I'll just stop the recording now and go ahead and do the rest of them. And the wing is complete at this point. Now that the wing is complete, I wanted to make just a few comments about the stabilizer. I'm not going to go into any detail on the construction of the stabilizer because it's identical to the wing. I mean, the same techniques, procedures, and so on. But I did want to show you a few different design concepts for stabilizers, and each one of them, has, again, advantages and disadvantages. The one that I built for this particular airplane that we've been building during this tape is this one here. And hopefully you can see that I've used the double diagonal concept again, wherein I have a spar on the bottom and then diagonal ribs going from that spar to both the trailing edge and to the leading edge. That gives probably the lightest tail construction that you can get, and yet fairly good stiffness. Hopefully this will be stiff enough. I think it will. Another approach is to use a sheeted leading edge with diagonal ribs behind the main spar, as is the case with this tail. And you can see here that the designer used an additional spar back in here to stabilize these diagonal ribs, much as we did on the wing, only we used the Kevlar thread. Now this extra spar could be added to a wing and do the same thing as the Kevlar thread, but it obviously is considerably heavier, and so that's why I went to the Kevlar thread rather than adding a spar. Now this tail is another approach. It uses the same construction technique, or design rather, as you might have for a wing, where you have a main spar, fore and aft ribs, diagonal ribs, and then turbulator spars between the leading edge and the main spar. So that gives you an idea as to the different approaches you can take in the structural design of a tail. I have, as I mentioned, tended toward this double, what I call the double diagonal, or the full crisscross, if you will, because I believe that it is the lightest, but yet provides adequate stiffness. So now we'll go on and build the fuselage now that we have the wing and tail complete. And next scene we'll be talking about how to build the pylon. All right, now the first thing I make when building the fuselage is the pylon, because we'll use that in the construction of the main part of the body. The pylon is made up, in this case, of 1/4-inch balsa. I used 6 3/4 pound stock, C grain. The grain runs vertically, or what would be the vertical direction when it's properly situated on the airplane. So to do that, then you have to join several pieces of 3-inch wide stock together on edge. I sand the edges of the stock so that I get a good tight seam. Then I use the thick CA and run just a fine bead down them and then butt them together. I have done that in this case. I have cut it out to the proper size and shape so that it's ready to install into the fuselage at this point. So that's the pylon blank. The next thing to do is to build the wing platform. Now, there are two ways to build a wing platform. One is to just make a flat platform with a couple of squares on each side to accommodate the wing dihedral. I have gotten into using what I think of as a fitted platform, wherein the platform actually has the angle of the center dihedral of the wing, such that it is a custom fit, if you will, on the wing. In order to do that, I've made up the blanks, and there again, the grain on the platform runs span-wise to the wing to give you that extra stiffness in the rocking motion of the wing. I have cut out these blanks. I have cut a bevel on the center joint such that it joins together at the angle of the wing. And then in order to ensure that I have a perfect fit, I'll assemble the wing platform right on the wing itself that I'm going to use. Now to do that, I've taken a piece of wax paper, put a light coat of the 3M spray adhesive on it, and stuck it to the bottom of the wing. Now I'll take, again, the spray adhesive, put a light coat on the wax paper so that I can stick the two pieces of the wing platform to the wing. Make sure I get it right so that I have the bevel in the proper orientation, which gives me that. Now I can just go ahead and using the center seam of the wing, position one half of it, and it's pretty important because this generally gives you the correct lineup of the wing with the fuselage. So we want to get this seam as perpendicular as we can to the leading edge of the wing, and we do that by just lining it up with the joint in the wing. And you can see that, or I can see that it is lined up, and we'll stick it down. Then we'll take the other piece and put a bead of glue on it. And then just fit it right up against the existing piece. Now this is end grain balsa that we're gluing here, so I want to use the thick adhesive, and it soaked right into the end grain, so I'm going to put another coat on. Okay, there's a glue bead on there now. So we'll just take that and lay it right on there. A nice tight glue joint now. So now we've got a wing saddle that will exactly fit the wing when we put the wing on the fuselage. Well, the next step then is to attach the wing platform to the pylon blank itself, and we want to do this with quite a bit of care so that we get this seam lined up right down the center line of the pylon blank itself. And then we also want the pylon to be perpendicular to the plane of the wing in this direction. So the way I do this is to mount the platform loosely to the pylon with some short model pins, and then once that's done, I can set the assembly on the bench, use these combination squares to make sure that it's perpendicular then to the plane of the wing. So I guess there's one other thing that I'd like to mention, is that since I'm going to be making the initial adhesion of the platform to the pylon with the thin CA, I have prepared this end grain joint here on the pylon by rubbing in a coat of the thick CA glue to give us glue base for the thin CA to adhere to. So I'll go ahead and mount this thing on here. It takes a little bit of time and patience, just to make sure that you got it lined up as best that you can. I've now got the platform pinned to the pylon blank, and you can see that it's being held there, but it's certainly not rigid by any means. So now I take the two combination squares, put one on each side of the pylon, and make sure then that it is perpendicular to the plane of the wing, which is determined by the wing saddle. So now we have it perpendicular. I can just take put a little downward pressure on it just to make sure that we're seated properly. There, move those squares up against it again. Now I can just take the thin CA and run down the joint on both sides. And I guess that brings up a point that I've thought about mentioning a few times before. And that is, CA apparently does shrink a little bit when it cures. So if you're trying to get something perpendicular, and if you put a bead only on one side, it won't be perpendicular, because when the stuff cures, it'll pull it over. So you need to put a bead down both sides so that it cures evenly, and then it will stay perpendicular. So I'll go ahead and run this bead down here. And we'll get one on the other side. I think I missed a little place here, right there. Okay. Well, that then adheres the platform to the pylon, and everything is squared up and perpendicular. Now the next thing to do is to put some triangular stock in this joint, and since it's not a right angle, it's not a right triangle here. We'll need to bevel one edge of the triangular stock so that we get a good, nice fit in there. Then after the triangular stock is glued in on both sides, then I just take a drill and by hand drill into the pylon blank from each end to install a dowel. In this case, I'll be using an 1/8" dowel to use for the rubber bands to hold the wing on the airplane. Now that the pylon assembly is finished, the next step is to cut out the fuselage sides. I might mention that I typically keep track of the weights of the various sub-assemblies as I build an airplane, and in this case the pylon sub-assembly weighs 32 grams. So that'll help me in the future in determining what something is going to weigh. So I've cut out part of the fuselage side out of a piece of 36-inch long stock, but the fuselage is actually 44 inches long, so we need to splice on another piece. And the way I do that is that I get the two pieces lined up on edge like that, maintaining that alignment. I lay them down, and I take a straight edge, and I cut the diagonal splice line. Now, in full-scale aircraft, in the repair manual for wooden aircraft, they require a 12-to-1 ratio on that angle. Well, actually, that's considerably more than we need for models. I try to use something in the order of 30 degrees, but not as steep as 45 degrees. So you can see here I'm using over about a 1 5/8 width. I'm using about a 3-inch stroke. So it's something approaching a 30-degree angle. So let me slice that off. cutting through both pieces at the same time along a straight edge. Now it's very important to get a good joint here, as you can probably understand. So what we're going to do then is to move that over to the edge of the bench, and with the sanding block, sand both pieces at the same time so that we maintain a consistent angle and get a good face for the joint. And then we take that piece and flip it over, and we have a perfect alignment. And then it looks good on that side, and we'll turn it over and see how it looks on the other side to make sure that the sides aren't beveled or anything. And that looks very good. So we'll take a piece of wax paper and then lay the two pieces on there and glue them with the thick hot stuff, and that'll be one fuselage side. Now on the other side, I will make the angle or the splice go in the opposite direction. I don't know that that's particularly important, because probably the glue joint is going to be stronger than the basic wood anyway. But I always feel a little bit better by reversing the angle of the splice. And this splice, I might add, is located on the fuselage such that it'll be backed up by the pylon itself. So there should be no problem with this splice ever breaking. All right, we now have the fuselage sides cut out, cut the shape and size. And the next step is to cut the fuselage top and the bottom. I might mention a little bit about the materials that I've used. This airplane that I'm building during the development of this tape is a Class B airplane, 600 square inch wing area. And for the fuselage, it's going to be 44 inches long. So I've used 3/32 8-pound stock for the sides, and I will use 1/16 8-pound stock for the top and the bottom of the fuselage, but the top and the bottom will be backed up with 3/1000 carbon fiber. So I'm getting ready to laminate the carbon fiber onto the 16th balsa that I'm going to use for the top and bottom. And in order to do that, you need to prepare the surface of the carbon fiber, because it's quite smooth and shiny as it comes from the factory. And to make sure that you get a good adhesive joint, you want to roughen it up a little bit, and then I wipe it off with acetone or lacquer thinner to take off any wax or any residue that might possibly be on it. So then, once I get it all sanded, I will take the slow drying CA glue and smear it all over the piece of the blank here. Then I will stick that onto the balsa. Then I will go ahead and cut out the specific precisely measured top and bottom for the fuselage. Now the fuselage sides are cut out, the top and the bottom are cut out, and you can see that the carbon fiber was not quite as long as the fuselage is. So rather than splicing it in, we don't need the strength up here in the front end anyway, because of the pylon itself. It's going to provide a lot of stiffness and strength up there. And primarily where I wanted the lateral stiffness is in the tail boom of the fuselage. Another thing that I've done is that I was very careful to draw a center line right down the middle of the top, and then I cut out a slot through which the pylon will slip into the fuselage. And it's important to get that slot cut accurately, because that is your pylon alignment. The center line that's drawn on the wood is important for lining up the fin with the pylon in the final assembly of the airplane. So now we're ready to start assembling the fuselage. We've got all the parts made. So the first step is to spray a light coat of spray adhesive on this wax paper that I have, that I've already laid down. And then we'll stick down a straight edge. And the reason that we do it this way is to make sure that the fuselage is as straight as it possibly can be, because you don't want any curves or warps built into the fuselage. So I'm pushing it up against the straight edge, and at the same time pressing it down onto the wax paper. All right. Now we can lift up the straight edge, and if I can get my fingernails under the edge of it there. There it comes. Okay, the next step then will be to put the uprights or the bulkheads in the fuselage. And I'm going to sign off while I do that, because I've got to mark, use a ruler measuring from the plans as to where the bulkheads are located. So I'll make a pencil mark on the wax paper there and install the bulkheads, and then we'll be back. All right.